You're listening to Science Friday. I'm Ira Flato. We could be ushering a new era of space travel tomorrow, one where private companies, instead of NASA, carry cargo and maybe astronauts into space. At 4:55 a.m. tomorrow, scheduled for tomorrow, the SpaceX company is hoping to launch its Dragon spacecraft from Cape Canaveral. The Dragon will be carrying a payload to the International Space Station, and if all goes as planned, SpaceX will be the first company to send a commercially developed, launched, and operated craft to meet the ISS, though much of the money for it still comes from taxpayers. SpaceX won't be delivering any astronauts for now, but that's part of the plan for the future, since without the space shuttle, the U.S. is relying on the Russians to taxi people back and forth to space. Joining me now to talk more about it is one of the folks who will no doubt be watching the launch, probably biting his nails a bit, Elon Musk, CEO, Chief Designer at the Space Exploration Technologies Corporation, or SpaceX. He's also CEO and product architect for Tesla Motors. Welcome back to Science Friday, Elon.
Thanks for having me.
Lunch tomorrow. Give us a sequence of what's going to happen over the next few days.
Yes, launch is tomorrow at 4:55 a.m. Cape Canaveral time, which is where the rocket launches from, or say 1:55 a.m. California time. I'll actually be here in California at SpaceX headquarters at Mission Control. So we have launch control at Cape Canaveral, and we've got mission control here at headquarters in California. So for the first 9 minutes or so, the rocket will be ascending and delivering the Dragon spacecraft to orbit. And then the Dragon spacecraft will separate from the rocket and begin orbital phasing with the space station, which will take a few days. Then we're going to do essentially a flyby of the space station. Now, something that's important to appreciate is that the space station is actually zooming around the Earth at 17,000 miles an hour. People sometimes think it's just sort of up there and stationary, but it's zipping around the Earth, and it actually completes an orbit of the Earth every 90 minutes. So you can think of this like you're trying to synchronize speed with something that's going 12 times faster than a bullet from an assault rifle. And we've got to match the space station. As the space station makes small movements in its orbit, we've got to track those movements exactly. So we'll do a wide loop around the space station, establish a communication link with the space station, have our docking sensors lock on, and then the spacecraft actually plots an approach vector, and we'll go in and pause at various points before finally going into dock with the space station.
Mm-hmm. And at what time into the mission will it actually dock?
There's a little bit of variability there because it depends on how things are looking and whether we need to upload new software or new navigation vectors. But it should be around 3 or 4 days after launch.
And so Mission Control, NASA will tell the space station crew they go for capturing, or is that up to you guys?
It's a joint effort. Both NASA and SpaceX have to be green for the docking.
Mm-hmm. And as you say, they'll do a flyby. Will that mean the astronauts will be looking at the state of your space vehicle, the Dragon?
Yeah, absolutely. They'll see Dragon doing a loop around the space station. It's a pretty wide loop, so Dragon will still look pretty small from the space station when it's doing that wide loop around the space station. But I mean, just to visualize things, it's like literally imagine you're doing a loop around a bullet that's going 12 times faster than something that came out of an assault rifle. So it's a dodgy affair.
I know, and they first tried this in the 60s.
Right.
Docking in orbit was accomplished in the 60s. I think Gemini 2, whatever it was doing, Ed White was involved in some of those things. Anyhow, so are you sort of relearning all these spacey things that astronauts have been doing for years?
Yeah, I mean, to some degree what SpaceX has been doing thus far is kind of catching up to the present state of space technology, and now we're beginning to, I think, exceed it. And in the coming years, we're really going to push the frontier of rocket technology to places that it's never been before.
And so what is the ultimate goal? Is it to create a substitute cargo ship like the Dragon, or is it also to bring people into space?
Absolutely to bring people. And in fact, the cargo version of Dragon is very similar to the crew version. In fact, even the cargo version has windows. And if you were to stow aboard Dragon and hide out amongst the cargo, you would actually have a pleasant flight up to the space station, assuming things go well.
So no monkeys for you like NASA had. You just go up there without any people in it, but could have people if it needed to.
If someone stowed aboard, that'd be fine. So we actually will have some biological cargo, and in the future we'll be carrying plants and mice and various experiments to and from the space station. And it's quite big inside Dragon. In fact, we've got space for 7 astronauts. And we've been doing advanced work on the crew version of Dragon, which, like I said, is very similar to the cargo version, which has a great advantage because we're able to therefore prove out the system in cargo without risking human life.
So you've got the same human capacity as the space shuttle had, which was 7.
That's right, exactly.
At the same time,
but we're much cheaper. So we're about 1/8 the cost of the space shuttle, and I think a much safer design because Dragon, when carrying crew, will actually have a launch escape capability. So it has escape rockets to get away from the rocket if there's an emergency. And being an automatically stable kind of capsule or gumdrop shape means that the main heat shield automatically orients itself downward, even if there's a failure in the flight systems. And that means that you don't have to worry about, if you've got a plane, you've got to maintain a particular angle of attack, and you've got to worry about whether the various control systems are working properly, and if there's any flaw in that, then you've got a real problem. You don't have that issue with Dragon. And then we also have a double-layer heat shield and a much more robust heat shield as well. And then the new version of Dragon, the one that will carry crew, will actually be capable of landing propulsively, so landing on its thrusters, which I think is pretty cool. And it'll have a parachute backup, but it's capable of landing on its thrusters.
You mean like in the movies, the rocket ship backing up, landing on Earth?
Yeah, I mean, I think real rockets should land on their thrusters.
That's a good quote for today.
I mean, that's the best way to land. I think it's pretty cool.
Yeah, it is cool. How much has SpaceX spent so far, and how much of your funding comes from NASA?
Sure. So we've spent all in over $1 billion thus far, and NASA's maybe responsible for about 40% of that. And then we've got a bunch of private capital that's been raised, and payments from other customers, and for milestones that we've already achieved, and other launches that we've done. So it ends up being a great deal for the taxpayer, because it ends up costing much less than alternative approaches, and then particularly when we're launching crew, because right now, because of the retirement of the space shuttle, American astronauts have to go up on the Russian Soyuz, and it costs over $60 million per seat. And when our vehicle is flying, it'll actually cost around $20 million a seat, so it'll be a huge savings.
But there are already some skeptics in Congress. I'm going to quote Ralph Hall, head of the House Science Committee, quoted in the Wall Street Journal as saying, "I have yet to be convinced that a viable commercial market will develop for privately built spacecraft." Well,
I've had conversations with Ralph Hall. He's actually, I think he's a great guy. His skepticism on a certain level, I think, has merit in that this has never been done before, and there's no prior precedent. So, in light of that, skepticism is not unwarranted. But we've made great progress thus far, and we've successfully launched Falcon 9, the rocket, twice, and we've launched our Dragon spacecraft to orbit and brought it back safely already. And now with this mission, we're going to be docking with the space station. I think this mission will do a lot to convince people like Ralph Hall that this is the way to go.
But you only have one place to go. I mean, with this, right? I mean, can you build a business on just going to the space station?
No, actually, it's important to mention that SpaceX is of the launches we have under contract. So we have about 40 launches under contract, and of those, only 13 are for NASA. 27 of them are commercial launches, and they're for delivering satellites of all kinds, like communication satellites, broadcast satellites, things like DirecTV, right, XM radio, right, mapping satellites that do things like Google Maps, that there's a lot of satellites. In fact, most satellites that are launched are actually not government satellites. So
yeah. So you're trying to do what the shuttle would have done with a smaller cargo bay, but and be usable and come back, but land on your thrusters, as you say.
Yeah. That'll be version 2. Version 1, which is the current version, is parachutes to a water landing because that was the safest way to go in the beginning. But version 2 is going to be able to land on thrusters, and it'll actually be capable of doing missions to other parts of the solar system as well.
The moon?
The moon's it could potentially go to the moon.
How much cheaper, since you're doing this? What a quarter of the cost or something of what NASA or the Russians could do? How much cheaper could you get to the moon and back?
Well, I think it's probably it's sort of how much cheaper than what number, I guess.
Can you make it cheap enough to want to do it and to make it commercially feasible if no one else is going to do it?
I think we could. I'm actually fairly confident we could do manned missions to the moon, and in relatively short order, if we had a customer that wanted to do that. And we'll certainly have some interesting announcements in the coming years that I think people will be pretty excited about.
Does that include Mars?
Yeah, Mars is the ultimate goal, and not just to visit, but to be able to develop a system that's capable of taking ultimately millions of people and millions of tons of cargo to Mars in order to create a self-sustaining civilization and make life multiplanetary.
Talking with Elon Musk on Science Friday from NPR. So you're not afraid to think big. Now, there are very few big thinkers. There's always it's now it just costs too much to do something. In a multi-generational scale.
Yes. Well, there's a tremendous amount of technology that has to be invented in order to do what I just mentioned of create a civilization on Mars. But both in terms of the transport and on the infrastructure on the ground on Mars. And Mars is a bit of a fixer-upper of a planet, so it's going to take a little bit of work. But it's the only viable option in the solar system, and outside of the solar system is really not possible because of the distances.
You're also teaming up with Paul Allen for something called Stratolaunch. Does this dovetail with that? Can you describe that a bit? And does this dovetail with that, or is that a totally separate project?
That's a separate project, and the basic premise of Stratolaunch is that there are satellite customers who really want a lot of flexibility in launch location. So the rocket can be picked up by a giant aircraft, and the launch can occur almost anywhere on Earth. That's the basic idea with Stratolaunch, or that's the premise, but it's independent from our other activities.
It's just sort of like going back to the 60s with dropping an X-15 out of the belly of a bomber and shooting it up into space.
Right. It doesn't result in a cost savings, but it does result in increased launch site flexibility.
And just while I have you here for a few seconds, let's talk a bit about Tesla Motors, if you don't mind.
Sure.
I see that your powertrain is the battery, and the powertrain is showing up in a Toyota. The Toyota RAV4, electric RAV4 is we make the whole powertrain, so motor, transmission, battery pack, inverter, everything that makes it move. And this is a great partnership that we have with Toyota, and we're really excited to have that product come onto the market. And what about your own Model S? Can we see that soon?
Yes, in fact, the Model S will go into production. In fact, I should say, to be precise, we will start deliveries next month. Wow,
and you're expecting this to be... Are other companies, is your powertrain and battery situation such a success that other companies now are looking to license your technology?
Yeah, we don't yet license, although we're happy to consider such, but we do manufacture for and supply it to other companies. So our two main partners are Toyota and Daimler, who makes Mercedes and Smart. So we've got a Mercedes program where we're also going to be making the whole powertrain, and I think that's going to be a really compelling vehicle at an affordable price.
And how many cars with your stuff in it total do you think we'll be seeing soon?
Well, over time, I think we'll see long term, I think we'll see millions of cars with that are either Tesla or with Tesla components that our partners are making.
Mm-hmm. And how many in this country do you think within the next 2 or 3 years?
Well, every year that passes, I think you'll see dramatic increases. I mean, this year we expect to deliver about 5,000 Model S's, and next year over 20,000. And the year thereafter will probably be, 40,000 vehicles. So it's really increasing quite rapidly year over year.
Anything else that you'd like to do that you haven't done yet? You have something thinking about?
I should mention Solar City. Solar City will be doing an IPO later this year, and I think it's going to be a very successful IPO. It is definitely not easy making things work in the solar business, or rather, it's not easy making things work in the rocket business, car business, or solar business, frankly. These are not the places that anyone should pick if they're looking for the highest risk-adjusted return. But nonetheless, I think all companies are going to do pretty well and are doing pretty well. It's definitely not as easy as making money on the internet, though.
Yeah.
I mean, it would be
well, we're glad to see someone's trying some new things at least. Thank you very much, Elon, for taking time to be with us today.
You're welcome.
Someone who's taking a chance. Elon Musk, CEO and Chief Designer at Space Exploration Technology, SpaceX, also CEO and product architect for Tesla Motors. Our program senior producer is Annette Heiss. Charles Berquist is our director. Flora Lickman, our multimedia editor. Associate senior producer, Christopher Intaliata. Amisha Srinanan is our producer. Luis Quevedo, our Spanish language producer. Sam Flato is our production assistant. Neil Rauch, our technical director at the controls here in New York. Our iPhone app is produced by Pastime Software. And if you missed any part of our program, go to our podcast. Or better yet, download our iPhone and Android apps. We're continuing week-long discussions on Twitter at SciFri. And we have a new website. Go to our new website. New look, new design, new feel. Tell us whether you like it, how we can make it better. Take a visit. I'm Ira Flato in New York.